Okay, we're going to look at some more equation of the straight line. So remember that the equation of a straight line is given by y equals mx plus c. So let's look at some examples with downward slopes. Okay, so let's say we've got this one, and that's got y-intercept of 2, and that is the point 3 minus 2. Okay, so to travel from the origin up to 2, so that means that I move along 0, don't move along so that it's coordinate 0, but I move up to y coordinates 2. Okay, that's x coordinate and the y coordinate, put that in. Okay, so let's say label x1, y1 next to y2, so from left to right, the first x coordinate x1, so the first y coordinate y1, second x coordinate x2, second y coordinate y2. Okay, m equals y2 minus y1 over x2 minus x1. Okay, y2 minus y1 over x2 minus x1. y2 minus 2 minus y1, 2, so it's minus 2 minus 2 over x2 minus x1, so that's 3 take away 0. Okay, minus 2, that's minus 4, and 3 take away 0 is 3. I can't simplify that, it doesn't become a whole number either, so it's just a gradient of minus 4/3. Okay, what's the y-intercept? It's right there in front of me. C is equal to 2. So the equation of a straight line then is y equals mx plus c. M is equal to minus 4/3. And c is equal to 2. So it's y equals mx plus c. Y equals minus 4/3 x plus 2. Final answer. Okay, let's try an example 2. Okay, so this time I cut the y-axis at 5, and let's say that that is the point 4 minus 3. Okay, so let's establish this point up here. Okay, so to get from the origin up to 5, I travel along 0, but I move up 5, the point 0,5. Okay, so the first x coordinate is 0, the first y coordinate is 5, the second x coordinate is 4, and the second y coordinate is 2. Okay, m equals y2 minus y1 over x2 minus x1. Okay, y2 minus y1 over x2 minus x1, so it's minus 3 minus 5 over x2 minus x1, 4 minus 0. Okay, minus 3 minus 5 is minus 8, 4 minus 0 is 4. Okay, so 8 divided by 4 is 2, so minus 8 divided by 4, that's minus 2. You can see clearly that the y-intercept c is equal to 5. Equation of a straight line, remember, is y equals mx plus c. Okay, so m is equal to minus 2 and c is equal to 5, so substitute them straight in. And that's y equals minus 2x plus 5, final answer. Okay, example 3. Okay, so the y-intercept is 4, and let's say that that is the point 3 minus 2. Okay, so let's establish this point up here. To get from the origin up to 4, I move along 0, but I move up 4, 0, 4. Okay, so that's x1, y1, x2, y2. M equals y2 minus y1 over x2 minus x1. Okay, y2 minus y1 over x2 minus x1, that's minus 2 minus 4 over x2 minus x1, 3 take away 0. Okay, minus 2 minus 4 is minus 6, 3 take away 0 is 3, 6 divided by 3 is 2, so minus 6 divided by 3 is minus 2. You can see that the y-intercept clearly is where I cut the y-axis. I can get that immediately just by looking, and that's 4. Okay, y equals mx plus c, m is equal to minus 2, c is equal to 4, minus 2x plus 4 straight substitution, final answer. Okay, let's try an example 4. Okay, let's establish the first point to get from the origin up to 3. Well, that's 0 along, but it's 3 up, 0, 3. To get this point here, okay, to get from the origin along to 1, well, that's 1 along and 0 up, 1, 0. Okay, x1, y1, x2, y2. M equals y2 minus y1 over x2 minus x1. Okay, y2 minus y1, 0 take away 3 over x2 minus x1, 1 take away 0. Okay, 0 minus 3 is minus 3, 1 minus 0 is 1. Okay, so 3 divided by 1 is 3, minus 3 divided by 1 is minus 3. The y-intercept is clearly equal to 3. Let's feed that into y equals mx plus c. M is equal to minus 3, c is equal to 3, y is equal to minus 3x plus 3, final answer. Okay, example 5. And there's the x-axis and the y-axis. Okay, let's say that that is the point minus 3, 1, and I've got the y-intercept there, which is minus 4. Okay, so to get from the origin down to minus 4, that's 0 along and 4 down, 0 minus 4. Let's label the points from left to right. So x1, y1, x2, y2. M equals y2 minus y1 over x2 minus x1. Okay, y2 minus y1, minus 4 minus 1 over x2 minus x1, 0 minus minus 3. Okay, minus 4 minus 1 is minus 5, 0 minus minus 3, well the two negatives make a plus, so that's 0 plus 3. 0 plus 3, that's 3. The gradient is minus 5/3. What's the y-intercept? Dead easy. As per usual, z equals minus 4. Okay, so y equals mx plus c. That's minus 5/3 x minus 4. Okay, let's look at example 6. Okay, and we'll have that is cutting at minus 2 there, and that's cutting at minus 5. Okay, to get from the origin along to minus 2, that would be, well, you're moving minus 2 along and 0 up, minus 2, 0. And to get from the origin down to minus 5, well, that would be 0 along and 5 down, 0 minus 5. And let's label the points from left to right. x1, y1, x2, y2. M equals y2 minus y1 over x2 minus x1. Okay, y2 minus y1, minus 5 minus 0. Over x2 minus x1, 0 minus minus 2. Okay, minus 5 minus 0 is minus 5, and 0 minus minus 2, well, two negatives make a plus, that's 0 plus 2. which will give me minus 5 over 2. The y-intercept, that's what I cut the y-axis, that's clearly minus 5, c equals minus 5. Equation of a straight line, y equals mx plus c, y equals minus 5 over 2x minus 5. Final answer. Okay, example 7. Let's go for this one. So we'll say that is the point minus 3, 2, and that is the point where we cut the y-axis at minus 2. Okay, so let's establish what this point is. So to get from the origin down to minus 2, that's 0 along and 2 down, minus 2. Okay, x1, y1, x2, y2. Let's just label the axis just now. Okay, so m equals y2 minus y1 over x2 minus x1. Okay, so y2 minus y1, that's minus 2 minus 2 over x2 minus x1, that's 0 minus minus 3. Okay, minus 2 is minus 4. 0 minus minus 3, well, 2 negatives become a plus, that's 0 plus 3 minus 4 over 3. Okay, we can see clearly that the y-intercept c is equal to minus 2. So y equals mx plus c, y equals minus 4 over 3x, and the y-intercept is minus 2, so it's y equals minus 4/3 x minus 2. Now, just be careful at that point. What you might have noticed or might not have noticed is this time the y-axis was actually not called y, it was called v, and the x-axis wasn't called the x-axis, it was called t. Now that sometimes happens, that you got the axes called different letters. So if that happens, it's no problem. So normally we call the y-axis y, but if it's called v, you just replace y with v, and you just replace the x with t. So instead of y equals minus 4/3 x minus 2, well, if the y-axis is called v and the x-axis is called t, you just replace it and it will be v equals minus 4/3 t minus 2. Final answer.